Okay, so my presentation is titled Artificial Intelligence and Health Physics, or Health Physics. It's not totally about that. When they approached me a few weeks ago to speak, this was at the top of my mind. And so I want to just let you know that I am not an expert in this field, but I find it fascinating. I have always had a love for science fiction. I love The Matrix, as you can see the visual there on the screen. I've been a fan of the Terminator and some of the other, always kind of the dystopian fictions, right? And artificial intelligence taking over or somehow uh, causing trouble. I want to make sure. Oh, I didn't want to do that yet, but okay. It's kind of, hmm. I want to get back to the title, but I can't. That's what I'm doing. Oh, maybe I'm not. I'm okay. I was not clicking the right one. Sorry. So anyway, what got me interested though now is I attended a publications committee meeting for the Health Physics Society. It's the journal staff and website staff, and we all meet once a year in Virginia to discuss how to advance the publications of the Health Physics Society. So that meeting, the entire conversation was about artificial intelligence and how it's impacting the publications world. And I thought, wow, this future is really upon us now. And we need to start thinking about some of these things. So, as is often the case, as I said, I didn't end up writing exactly what I was going to, but hopefully we'll still have a good journey here. I keep hitting the wrong one. Okay, now I got it. Um, so artificial intelligence, the terminology was coined back in 1956 at Dartmouth College. So that's a long time ago. And now it's come to cover everything from smart cars to your smart assistants like Siri and Alexa. Pretty much covers, it's a very broad term that covers a lot of different areas. Machine learning is more specific, and machine learning is the idea that computers are programmed to then learn as they gain additional knowledge and additional data. They can actually learn from that and make predictions from that. Deep learning is really about using a neural network, which is modeled on the human brain, to convene to represent the function of human thinking. Because the whole idea going along in artificial intelligence is to be able to create machines that can do things that up until now only humans could do. And so we've gone a long way. Generative AI, which is available today, is an advanced form of artificial intelligence that can create natural language, it can create music, it can create art, it can write you presentations. If anybody has ever used ChatGPT, I know for a fact Brian has. Microsoft has a version. It's called Copilot, and it's fascinating to use these and to give them prompts and see what you get back from them. And even for those of you who don't think you use AI, you probably do. If you write texts or if you write emails, if you use social media and you start typing on your phone, this is actually an idea that Brian told me. The predictive text will come into play. And so it will start to spell the word that you're going to spell, but then it will also start to give you words, different words, before you even get the letters in there. Sometimes it'll give you a phrase. And so I was talking with Brian. He said, I found myself in writing some papers, the predictive text would come up, and I'd think, oh, yeah, I like that better. And use that text in the paper. So, the question to me is, does he need to share his authorship then with that AI program, which was one of the big topics at the publications meeting. So at the publications meeting, Brett Burke asked ChatGPT, what's a health physicist? And ChatGPT came back, and I thought I would share this with you all so that we could kind of bask in our own glory. Health physics is a critical and dynamic field. We play a crucial role in protecting workers and public from potential radiation hazards. We ensure that radiation is both beneficial and secure, and we are at the forefront of maintaining a delicate balance between innovation and safety. I thought that was an excellent, we're actually going to use this and put this on the Health Physics Society website because it's a better description than any one of us have ever come up with. So this is going to go up there. So I went home and I began experimenting, and I asked ChatGPT, I said, write me a procedure to calibrate a dose calibrator, right? Because I hate writing procedures. I don't know about anybody else. So it gave me something very generic, but it made sense. You know, simple things like make sure the calibrator is free of contamination. Make sure it's plugged in. It told me that. It said select your radionuclides that you are going to want to use. Get reference sources, measure those. So it went through the whole, the steps of the calibration. But what I had meant to, I asked it the wrong thing. What I had meant to ask it was, give me a quality control procedure for a dose calibrator. That's what I had really intended. So I did that. And it came up with, it hit every check mark, constancy, accuracy, linearity, and geometry. Now, if any of you are in the medical field, you will notice something about this. And that is, they get the frequencies wrong. For what is normally used in the United States, these are not the frequencies that are typically used. Now, I realized that when I read it, but I realized that because I already know that. I know what a dose calibrator QC program should look like, so I'm able to recognize, okay, they did a pretty good job, but it's really not right, and this is how it would need to be corrected. So part of the problem there is if you don't know the topic already, if you are not already educated on what it is you're asking about, you won't be able to recognize when they give you the wrong answer, right? So it's still, this is something, and it goes back to my thinking about how we felt about allowing calculators in school. Okay, I'm old, right? I was just at the tail end of the slide rules. And then they started bringing the calculators in, and they're like, kids are not going to learn math. They're not going to know what they're doing. They're not going to know if they're right. And all of those are very legitimate concerns, I think. But we continued to teach math. We continued to teach children and high school students to learn mathematics. And so we didn't lose that value. And I think if we're cautious with AI, we can do the same thing. There was an article published in 2020 on AI and radiation oncology. And for any of you who work in medical facilities, you are likely aware of the complexities of treatment planning. So this article talked about all the different areas in which AI could assist radiation oncologists in the treatment planning phases, actually all the way from deciding what treatment the patient might want, would be best for them, would have the least side effects, how to optimize that treatment. In the decision to treat role, the AI would be using imaging data, clinical data, genomic data, medical history, comorbidities, all the information not just about that patient, but about thousands, perhaps hundreds of thousands, millions of other patients of the same, of a similar population, right? And so they can take all that information and be able to say, you know, these are the treatment options, you know, that would be best for you. And then in the planning phase, AI can help with tumor segmentation and organ segmentation, which is a very tedious process when you are trying to determine the contours of a tumor so that you do not irradiate too much healthy tissue, it can be a very complex matter to determine where the end of that is. And so the projection is, and AI is doing some of this now, but not the large learning models, not the generative AI at this point. And even in the follow-up phase, they discuss the fact that with the assistance of AI, there could be a better prediction of the late onset toxicities that might occur in an individual. So the treatment plans would be individualized. The follow-up likewise would be individualized. So all this, we still have a long way to go. This was written in 2020. This is not reality. It's not going to be reality tomorrow. It's probably not going to be reality for quite a while yet. And there's the regulatory issues that go along with this. The FDA, it was only October 23rd, 2023, October 19th, 2023, that they first posted a list of artificial intelligence and machine learning enabled medical devices. So these are like, some of them are the robotic surgeries. Those are all medical devices. There are also some treatment planning systems that already do incorporate some element of artificial intelligence. Imaging systems, imaging processing systems, all of these are medical devices under the FDA. And so they all have to go through that approval process. They all have to go through clinical trials. And the FDA is still working out how some of these will be approved. And you'll note the note at the bottom says to date, they have not approved any, any devices that use generative AI or large language models. So they have not gotten to the point where they are actually approving those generative AI models, which are designed to learn and designed to then essentially reprogram themselves. And so this is a conundrum the FDA is facing. When they approve treatment planning systems, they're approving the algorithms that will produce the results for those treatment plans. Now, I don't know how detailed an analysis they are. Excuse me. But imagine then trying to design a regulatory program that is going to approve a software that starts out with one very large set of algorithms, including learning algorithms, and that software is going to change over time. And it is not predictable how that software is going to change over time. And yet they still are going to have to provide some way to make those approvals, because this technology is here today. It's not being used yet in that way, but it's going to be. So another field, of course, that constantly they predict that radiologists will be eliminated by AI. There was a study in 2022 that was published in the British Medical Journal comparing radiologists to an AI program in reading radiographs. Now, the graph at the top, well, let's start with the graph at the bottom. The graph at the bottom, the purple lines are the average of whatever the selected number of radiologists they chose to have read these scans. And so the scans were actually from the Fellowship of Radiologists. It's the British Fellowship. It's basically the British ACR, their accreditation organization. And so they took retired exams and they showed them, they selected radiologists who had passed those exams. And so they had a set of radiologists, and then they had this AI program that was taught to read films, and they compared them. So the bottom one, the AI program didn't, I don't think there was one one case where, one question where they did do better than the radiologists, but otherwise the radiologists were still beating them. In the top case, what they did with the data is anytime that the AI program said that this image is not readable, it's uninterpretable, they took those out and they said, okay, let's just compare the ones that the AI program identified as interpretable and see how they do against the radiologists. The radiologists still did better. AI did a little bit better there, but radiologists are in no way in danger of losing their jobs right away. So, excuse me. All these advances and predictions about an AI-driven future also depend really heavily on the data that the neural network or the algorithm is using to learn from, right? You have to have, number one, a lot of data, but it has to be quality data because you're going to have terabytes of information from the genetic level to the cell level to the tissue level to the organ level to the organism level that is going to be analyzed in these medical applications. So it's a phenomenal amount of information, and it's very hard to ensure the quality of all that information, not to mention the consistency of that information. I think I have it here. This is a little bit busy, but if you look at the top line there, not in the table, left optic nerve. So these are from 12 different institutions, and this is how they label left optic nerve at various institutions. And this is just 12 institutions, right? If you go all over the world, you're going to have 1,000, 10,000 different designations for the same body part. So just collecting the data is one thing. Homogenizing the data is a totally different thing. And then ensuring that data, that the source of that data actually is a quality source. So there are a couple of large projects, the Cancer Genome Atlas, which began in 2006, and also the Cancer Imaging Archive, which was begun in 2011. And so these funded data collection entities are working on this and working on standards. So, what standard does the data have to meet for it to be useful to us? So there's a tremendous amount of progress that's been made since 1956. But we still have a really, really long way to go. And reliability of the data is really important to take note of. So I don't know if anybody saw the headlines about Michael Cohen submitted a brief which cited fake legal cases in there. They call that AI hallucinations, although I'm not sure if he's hallucinating or it may have drawn from something else. So this also occurs in research. And oops, let me go back. So this is Dr. Wu on the right-hand side. And Dr. Wu asked ChatGPT whether or not chronic stress causes people to crave familiar faces or places. And ChatGPT gave a very cogent answer to him, a long, nice answer, and cited a paper. And the paper was titled Chronic Stress and Its Influence on Familiar Face Recognition. And Dr. Wu said, oh, that's great. I'd like to know more about that paper. So they asked ChatGPT, tell me more about that paper. And ChatGPT gave a great, lovely answer and cited the same paper, but they cited the same title, but they cited a different publication journal and a different publication date. And that's when Dr. Wu said, wait a minute, does this actually exist? And he searched the volumes that they had cited, and they did not exist in those journals, and he could not find this paper anywhere. So potentially another AI hallucination here. Just to keep in mind, the reliability of the information is critical to, I mean, lawyers can get disbarred for this kind of thing, right? Submitting a legal brief. And the same for scientific journals. I mean, you can't be publishing with information that you haven't personally validated. So I don't know, do any of you edit or do peer review for the Health Physics Journal? Anyone? You? Do you go through and check every reference? that no. Okay, Tosh does. Good. Eric doesn't. Renee doesn't. I know I don't. I haven't done that. But now I'm thinking, well, I need to do that. And some of these papers, they come along and they have a list of 100 reference papers, right? And so now I don't know, is it a real paper they're referencing or not? And I know I have done some reference checking with respect to what the information it actually says, because I don't know if you guys notice this or not, but a lot of times you'll find a paper that references, that'll make some statement, a broad assertive statement, and then they'll cite to some other paper. And when you go to that other paper, you're like, that doesn't say that. So that's a totally different problem. That's a human problem, I think. But now we have this AI-generated problem to worry about as well. So the journal, as I said, that's what kind of sparked me along all this. And the journal has come up with a statement, statements and questions that they're going to add when you apply to have submit a paper for potential publication. They are going to ask you to identify whether or not you used generative AI in writing your paper in any way. So you will need to self-disclose. Now, I don't know how you enforce that necessarily, because there's a lot of ways you can use generative AI besides just telling it, write me a paper on, internal dosimetry. There's a lot more subtle ways you can, of course, use it. One of those ways is to upload your paper to, depending on the access you have to generative AI, but you can upload your paper to a system like that and have it peer review you before you submit it for publication. But you know what the problem with that is? The problem is for the publishers, and they are going to start prohibiting that if they can stop it, because once it gets into ChatGPT or Copilot or whatever generative AI program that you're using, once it gets into that program's database, it can continue to use that information as part of its learning, even though the paper has not been published and it's not been peer reviewed. And that's what I actually think happened probably with Dr. Wu, that it was not in fact an AI hallucination, that in fact it was a real paper somewhere. And not published, though. It had never gotten published. So they had probably submitted it to the one journal that was cited at that date, submitted to another journal at the other date, and the program was identifying that as a scientific work, even though it had never actually been published. That's my theory. It could be just a hallucination on the part of the AI, but I don't know why that would be an issue. And I guess it still doesn't explain the legal cases necessarily. So in any case, there is still a lot of work to be done. And that kind of brings me to the final thing I wanted to say about the quantity of information that's necessary, number one. The diversity of that information, that is, is that AI program actually getting a global input, and is that what everybody wants? What is the quality of that information? The reliability of that information. Reliability meaning the quality over time. basically. And then what are the inherent biases that the programmer puts into, or the developers uh, feed into the initial directions to these programs? Everybody has their own biases, and those biases are going to end up being reflected in a person's work. And then what about the learned biases? Because now you've got a program that's going to go out and be learning on its own. If it's already got inherent biases, is it going to increase that bias? Is it going to break away and become a full-blown liberal with no biases? Just kidding there. um, so I mean, there's a lot of things to watch out for, and none of this is known. So the code for ChatGPT is it's not in the public domain, right? It's proprietary. So there's not a way to be able to check on what information sources is it using, how is it validating, the information that it is using to produce answers, and so these are all things that we're going to have to watch out for as the future progresses. So finally, not finally, it's almost finally, I promise. Just thinking about the whole scientific process and how AI could interject itself in every, single part of this. And those biases then become even more important in a sense, because now as a researcher, if you come to things with your own bias, and the program's bias is going to lead you in a certain direction. And I think the thing that we have to keep in mind is the same thing as we did with calculators. We still keep teaching math. We still keep teaching science. We still keep teaching the scientific method. And we really have to enforce ethics in science, because it's going to be up to every individual scientist to be able to say, yes, I used AI in this part of my paper. Here's, here's, kind of the uncertainty associated with the use of that AI. And we have to really drill into people that they still need to be able to identify to some extent what it was or what it is that might be wrong with what is produced, just the same way we do a back of the envelope calculation in health physics. You look at a problem, and sure, I can't solve that exactly, or it's easier to have the program do it, but I need to know about what I am going to get. I need to have some idea of the order of magnitude, or where this is going to end up on some spectrum, in order to recognize whether or not the machine has actually produced the answer. Bullshit detector, yes. So no, let's see. So now this is really my final thought. Thinking about just these terabytes of data, all the way from the genetic material up to the organism level, and how it would be incomprehensible for a single human being to take all of that information and process it and analyze it themselves, and that this really is an advancement that can be very useful. And what I thought of in that moment was, in a way, we really, more than just our brains being representative of the neural network that they're building to use this generative AI. In some ways, we're like a 300,000-year-old organism, right? We're a neural network of neural networks that learned through time. We learned our own algorithms, from fire to the wheel to agriculture to architecture, math, physics, science, history, unraveling the mystery. All started with the Big Bang. Anyway, so I realized that we really are. It seems unfathomable the amount of information that this has to process, but in some ways, we've been doing that for hundreds of thousands of years, and so we just need to be vigilant and be diligent in our science, and that's what I wanted to share with you on artificial intelligence. Now I'm going to share a couple health physics things real quick. The Health Physics Journal needs reviewers. There is a news article in December 2023. These links are actually live, so you can, if you're interested in becoming a reviewer for the journal, there is also a reviewer tutorial, which is referenced here in a link that talks about how to peer review. They always need peer reviewers. They also always need papers. If anybody is doing any research, let's submit that to our journal and support the journal. I wanted to mention social media. So up on the top right corner there, you see circled. We're on Twitter, Facebook, LinkedIn, Instagram, and YouTube. We also have the National Society has a YouTube channel. So click on any of those icons, follow the Health Physics Society on there. You won't be sorry. And finally, we are getting a new website. So this is an article in the February 2024 newsletter. I'm on the task force, and we are hoping that we will have a new website probably by the end of 2025. It's going to take a little time. It's a lot. It's a big project, and we're not doing it ourselves. The task force is tasked also with identifying a qualified vendor to help us. But there is a survey form that is still live on the web, and that's linked in here, and also in the 2024 newsletter, where you can give your input on what you want to see in a website. So that's it. Thank you guys.